Today, we're going to simplify radicals. If I gave you a quiz corrections to do, if you can knock that out real quick and turn it in, because I need you following along on the notes today. But quiz first. Now, right holiday for Friday, right? Easy warm up tomorrow. And we're going to pick that up here in a minute. First, we're going to note Stars play the Avs tonight, even though this is an image from last year. Whatever. We're going to win, right? And if we don't win tonight, we're going to win on Saturday. Go to the next round. All right. Well, don't forget what Buff SpongeBob says, no work, no credit. You got to show your work. Now, number one, this is some basic stuff you should already know, like multiplying number times itself. 6 times 6 means 6 squared, which is 36, right? Does everyone know 6 times 6 is 36? You got to know that. Now, what if I take that 6 times 6 and square root it? Well, square rooting takes away one of the numbers you're multiplying by itself, right? So 6 times 6 is 36. Square root of 36 is 6, right? So what does that mean? A square root and a square cancel out, and you get 6, right? Square root, square, cancel out. Number 4, if you have x squared, and I'm trying to get rid of the squared, right? If I want x by itself right here, to get rid of a square, I square root, cancels out, gives me just x, and we already know that the square root of 36 is 6, okay? So these are different things we got to know. A number times itself is a number squared. If you square root that square, cancels out. And if it's in an equation, to get rid of a square, you square root, you can solve, right? Little basic things we got to know. I'm going to pass out today's notes, and then I'll pick up your warm-ups, and then we're going to do this warm-up. All right. I'm coming for those warm-ups right now. Make sure your name's on the warm-up, of course. All right, warm-ups. You can get off Google Classroom. I can do it. Yeah, post the videos. They should be posted. All right. So, since this is brand new, let's focus up here, please. Here we go. New thing. Simplifying radicals. It's possible you've done this before, but I don't think so. We'll see. All right, ready? Let's get this over with. First things first. Square. When I say the word square, what do you think of? Probably the shape, right? But, by the way, headphones? You don't got headphones, do you? Ay, chihuahua. Now, squares can be not only shapes, but also numbers. So on the left one over here, all those numbers are called square numbers. And why are they called square numbers? Because it's a different number squared. What times itself is 4? 2. 2 squared. If you square a number, that result is called a square number, okay? And then 9 is what times itself? 3 times 3, 3 squared. 16 is 4 times 4, that's 4 squared. 5 times 5 is 25. 6 times 6 is 36. You see the pattern, hopefully. So let's fill this in. But I want you to do more than just fill it in. Do you see the square numbers? I want you to be able to recognize these square numbers. So when you see the number 49, you already think, oh, that's a square number, 7 times 7. Duh. Okay, I think you know 100, 10 times 10, right? I think you know 81, 9 times 9, 64, 8 times 8, okay? Hopefully. But if not, you want to recognize those numbers. So here's the deal. What happens if you square root a square number? It's kind of like a warm-up. The square and the square root cancel out. So square root of 4, what times itself is 4? Well, we know it's going to be 2. Square root of 9, what times itself is 9? It's a square number, so it's 3. Okay. And you see the pattern here, right? If you take all these square numbers and do the square root of the square numbers, you get whole numbers. So the reason I'm showing you this is because certain square roots give you a whole number, and those are nice, pretty numbers, right? But I want you to notice, how many numbers are there between 1 and 100? There's 1, 2, 3, 4, 5, 6, 7, 8. There's only 9 numbers that would give you a square root of a whole number. So that means between 1 and 100, 91 other numbers would be a square root with a decimal that doesn't repeat with no pattern, okay? They're rational numbers. So here's the deal. When you have a square root that's not a square root of a square number, we got to be able to do what's called simplifying, okay? Simplify that radical, okay? So I'm going to show you how to do that. Now here's the notes, okay? We're going to do what's called a factor tree. This is not a trick question. Which way do trees grow? Up, yes, but also down, right? Y'all know roots exist, so they grow up and down. The reason why I tell you that is because when we're doing our factor tree, it's really going down, but that's okay because do trees grow down? Roots keep it in the ground, otherwise they'd fly away. Now, I'm not going to read all this. I'm going to just show you how it's done, but this is important. Before we get into this, you got to know what a prime number is. So when I say prime, I ain't talking about no Amazon. I ain't talking about no Colorado college football coach. I'm talking about prime numbers, okay? What's a prime number? Now, let's just see. Does anybody actually know what a prime number is already? Maybe. All right, so I got something new for you to know today. Prime number, ready? Okay, a prime number cannot be factored by anything else besides itself and the number 1. So here's what I mean, okay? Don't write this down, but if I give you the number 10, did you know 10 has some building blocks? There are some numbers that multiply to make 10. What multiplies to make 10? 2 times 5, right? Don't write this down, but I'm just saying, like, there are building blocks of the number 10, right? So if a prime number has no building blocks. So for example, the number 2, what multiplies to make 2? That's a whole number, just 2 and 1, right? So that doesn't count. The same number doesn't count. 1 doesn't count. Okay, so here's the deal. We got to know what our prime numbers are. I wrote them on the board over here in orange, okay? But the smallest prime number is not 0 and it's not 1. The smallest prime number is 2, okay? 2 is the smallest prime number, okay? After 2, okay, and I'm going to put it off to the side here when we're talking about prime numbers, prime. 2, then you have 3. Nothing multiplies into 3 besides itself, and 1. But 4 is not prime because what multiplies to make 4? 2 times 2. Yeah. So after 3 is 5. 6 divides by 2, so no. 7 is prime. 9 is not prime, divides by 3. 11, 13, 17, 29. Anyways, it keeps going. Okay. 23, I should have said, my bad. Anyways, so prime numbers are special because they're the building blocks of other numbers. Okay, why am I telling you this? When you have a square root, you need to break it into all of its prime factors. It's called prime factorization. It's the building blocks of the number. And the reason you do that is so you can simplify. So let's do that on example 1. So I'm going to zoom in here on number 1. We're going to make a factor tree. Everybody do this with me. Go ahead and it's more of a root system, but we're going to break 50 down into 2 numbers. Hear me as I say this. we always try the smallest prime number first, which is 2, okay? So you always try to divide by 2 first. So here's the question. Does 50 divide by 2? And I'll tell you, if it's even, the answer is always yes, if it's even. 50 is even, it ends in a 0. So here's what we're going to write. 2 times what is 50? 2 times 25. Now, here's the deal. Okay, here's the deal. So if you're not sure, here's what you're going to do. 50 divided by 2. If you get a whole number, then that works. And it does work. So on this one, 2 times 25 is 50. Okay, so do we always start with 2? Yes. Start dividing by 2. When you break it down, you got to cross out what you just broke down. It's gone. You broke it into 2 pieces, 2 and 25. Now, let's do the same thing with 25. That's not prime. Does 2 go into 25? If I was not sure, I would do 25 divided by 2. Does it give me a whole number? No, 2 does not work. The next prime number is 3. Does that give me a whole number? No. Okay, so 2 doesn't work, 3 doesn't work, 4 is not prime. So let's try 5, and maybe you already know this. Is 25 divided by 5? Oh yeah, 5 times what? 5 times 5. Cross out 25. You broke it down. All right, so we just did a factor tree. We have prime factorization. 5 does not break down because it's prime. So there's only 3 numbers that make up the number 50. 2 times 5 times 5. Cool. Now, this is where I'm going to tell you a story. Y'all want to hear a fun story? I promise. You'll laugh, you'll cry. There's drama, there's intrigue, there's tragedy, all the emotional spectrum. Y'all ready? All right. So, as you can see, I'm wearing my guayabara because it's fiesta season, right? All right, so I'm going to tell you a story about a party, right? Y'all know I'm a teacher. Did you know fiesta means party? Oh, you already knew that. So, this is not just any party. This is a house party. Ooh. Okay, and by the way, this story I'm telling you is in the world of numbers. Okay, look up here. Look, I'm telling you a story. Okay, novela, right? Check it out. This is the world of numbers, where there are no people, there are only numbers, and they have humanoid capabilities. Ready? Okay, so this world of numbers, there was a house party, but it wasn't just any house party. It was a radical house party. All right, draw a radical for me, please, on your paper. All right, so it's a radical house party, and only the prime people can go to this party. All right, so it's a radical house party. Only the primest numbers are invited. And guess what? 2, 5, and 5 are invited. Now, just like any teenage party, these 2 individuals see each other from across the room. Their eyes light up. They realize, wow, that number looks just like me. It has the same values that I have. Values, get it? The number 5 sees another number 5, and they're like, wow, just like me. And guess what they decide to do? They become a couple. Everybody, circle this couple. Say, oh, so cute. Okay, cute. All right, so whenever you got the same number, it's so cute. It's a couple, right? Now, this is not a trick question. When couples are couples, what do? I'll tell you. They go out on dates, right? So this couple is going to go out of the radical house party. And which way is out? It's to the left, right? They're not under the roof. They're going to go out to the left. Cool. So they're going to go out, maybe go to a movie and whatever. Okay. It's going to be totally cool. Now, here's the deal. This is where tragedy strikes. It's so sad. Okay. It's one of those teenage tragedies, right? As they walk out of the radical house party, one of them steps on a landmine and just disintegrates into dust. It's so sad. And so what you have to do is you have to cross one out. It's so sad. In one moment, soulmate was found. In the next moment, forever gone. I can't explain it. You can't explain crazy stuff like that. So guess what? The 5 goes out here because the couple goes out to the left. And guess what? The only thing left is this loner. And the loner stays in the house and watches Netflix by himself. But you know what? Didn't step on a landmine, so it's all right. And that's the story of the Radical House Party Fiesta. All right. Now, what did we learn from my little story here? You make a factor tree, you circle the pairs, one of them is gone, and then pairs go out, loners stay in. That's the story, and I'm sticking to it. All right. You like that story? All right. Make it into a movie. Just give me credit. Now here's the deal. The only thing that would make this more complicated is what if there's more than one couple, or what if there's more than one loner? So I'll tell you, whenever, and there's one answer to this question. If there's more than one loner or more than one couple, you're going to multiply. What are you going to do? Multiply. So I'll say it one more time. If there's more than one couple, multiply. If there's more than one loner, multiply. So let's see that in action here. Let's do number 2. Ready? Okay, square root of 24. What am I going to do first? Make my tree, my root system. And I'm always going to start with 2. Does 2 go into 24? 2 times what is 24? 2 times 12. Write it down. Cross out 24 because you broke it down. All right, 2's prime. What about 12? Does 2 go into 12? 2 times 6. Yeah. So, okay, 2. 2 times 6. My pen is acting up. All right, cross out 12. 2 is prime. What about 6? Is 6 prime? 2 times what? It is 2 times 3. Cross out 6. And now 3 is prime. There's nothing else we can break down. So we got 4 prime numbers going to our radical house party. Now look at me. We're not doing anything weird. Only couples, right? Okay, so do you see any couples here? I see a couple of 2. We don't believe in thruples. That's crazy. All right, so couple of 2. And I hate to say it, it's so sad. They're going out. One of them gets gobbled up by a land shark. Because land sharks exist in number world where everything's crazy. All right, so cross one out. So the 2's going out to the left. Now, what did I say? If there's more than one loner, by the way, they don't have the same values. They didn't vote for the same president. They don't like the same genre of music. They're not a good couple. They don't fit. All right, one of them doesn't have the riz or whatever y'all kids say. All right, so here's the deal. Since they're not a couple, they're 2 loners. What do I do with them? Multiply is what I said. 2 times 3 is 6. And that's it. Guess what some people are going to put? They're going to put 5. Do not add them. Multiply. Cool? That's it. Radical house party. Ding, 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 ding. All right. Example 3. Y'all ready? 180 seems big, but I'm telling you, if you cut it in half a lot, it's going to make it a lot easier. That's why we start with 2. So does 2 go into 180? 2 times 90. Scratch out 180. 90 ends in a 0. That's even. So 2 times 45. Scratch it out. Now, does 2 go into 45? If for some reason you didn't know that, you could try it out and notice how this is a decimal. No. So let's try 3. Does 45 divide by 3? It does. 15, right? So it's going to be 3 times 15. Okay, always start with 2, then you try 3. Does 3 go into 15? What do you think? 3 times 5. Is 5 prime or do we break it down? 5 is prime. So this number, 180, has 5 building blocks. 5 prime numbers that multiply to make 180. All right, so again, radical house party. Do I have any couples? Couple of 2. Hey, and another couple of 3. Cupid strikes twice, but so does the Grim Reaper. It's so sad. All right, so we have 2 and 3. What do I do if I have more than one couple? Multiply. And again, they go out. 2 times 3 is 6. Loner 5, Netflix by himself. Okay? That's how you do this. Okay? So if you remember the little story, it helps you helps you with this. Flip it over, please. Let's do example 4 and 5, and I'm going to let you try some practice. Example 4 is a huge number. Does anyone still need 3? Okay, look at example 4. Stay with me here. 1260. That's a big number, but we can do it. Again, if you just keep cutting it in half, it makes life easier. It ends in a 0. It's divisible by 2. 2 times 630. Okay, you can use Desmos to divide it by 2 if you need to. It ends in a 0. That's even. It divides by 2. 2 times 315. Cross it out. 315 is not even, so let's try 3. Does 3 go into 315? You know, if you're not sure, oops, not sure, just give it a try. And 105, it does. So 3 times 105, scratch it out. 105, does that divide by 3? Now that one may not be obvious, but it does, okay? It's 35. 35 does not divide by 3. If you try, you will see. So we try the next prime number, which is 5. 5 times what gives me 35? 5 times 7, okay? Again, you just try numbers by dividing. If you get a whole number, it works. Cool. Once again, radical house party. Do I have any couples? What do y'all think? Couple of 2, couple of 3, 2 loners. If I have more than one of anything, I'm going to multiply, right? So let's do that. 2 times 3 is 6. 5 times 7 is 35. That is a simplified version of square root of 1260, okay? Real quick, because I want to give you time to practice. Number 5 here, or example 5. What's weird about this one is that it already has a number outside, right? Now remember in our story, if there's a number outside, it was already a pair, right? So here's the strategy. When you see a number outside, to help you remember it, I want you to already circle it. It's already outside, okay? And then we're going to do the factor tree. I'm going to do this a little bit faster. 2 times 38. Cross it out to 76. All right, 2 times 19. And then 19, if you try dividing it by 3, 5, 7, 11, it's not going to work, okay? 19 is actually prime. So we're done. Do I have any pairs? Pair of 2, right? Now, 2 is going out. 5 is already out. Guess what we do with the 2 and the 5? Multiply, right? Same answer. So 5 is already out. 2 goes out. What do we do when we are out? We multiply. 5 times 2 is 10. And then the loner is 19. The most common error on example 5 is people want to put 2 square root of 19. That is wrong. Why is that wrong? Because you forgot the 5 out front, okay? So I want you to try these 6 down here, okay? And last couple minutes, I'll give you the answers, okay? All right. Check your answers. Number 1, there's the pair and a loner, so 3 squared to 3. Number 2 has 2 pairs and a loner, so 2 times 2 is 4, squared to 3. Now 3 is weird, right? 3 only has pairs but no loner. So if there's no loner, then there's no square root. So that means it's just 2 times 3. But I want you to notice something. Don't we know what the square root of 36 is? Like, isn't that the first thing we did? The square root of a square number is a whole number. So that's why you want to just identify square numbers, because it'll save you some work. What about 4? There's no pair. If there's no pair, it does not simplify. You just rewrite it. There's nothing you can do. Number 5 and 6. The most common error is people try to circle the 2 and the 2, but they are not pairs because this 2 is already out. Then there's a couple 3, loner 2, loner 3, 6 squared to 6. Outside and pairs 15, loner 3. That's it. Okay. So make sure you keep these notes. We're going to use them on Monday. to do Pythagorean theorem. So have a great 3-day weekend. Don't encounter any land sharks, you know. Don't have a crazy radical house party, but have a safe fiesta. I'll see you on Monday.